So once I locate this part, I can go ahead and start tracing around my origin point that I have set up in CAM. If I did not know, for example, I was an operator and I was given the program and I was told to just go ahead and run it, sometimes that does happen out there. If I didn't know where this origin point was, I have a little indicator in the bottom left-hand corner telling me where I need to be probing for. But as you can see, very easily, all I did was trace out my part. I can go ahead and move things around if I need to, edit things out. And then if I'm satisfied with that probing cycle, I can go ahead and execute that. Another thing that the DATRON Pro brings that you might see is we have a little bit of a better user interface on this Pro. We have that LED that circles around the entire base so the user can get a better sense of the mechanical trigger points and what's going on there. Now that the part is probed out, this is just the dialog box saying, hey, I changed my 0 point. Do you wish to simulate based off of that new change? We can say yeah, and it brings me to that simulation, which the simulation is kind of like a last-minute sanity check for me to say, hey, did I accidentally go 10 inches instead of 0.1 inches? Or did I go and program in millimeters per se instead of inches or something of the sorts? It's some last sanity check. So I can go ahead and step through my part. I can look at the tools. I can look at all the way that the tool is going to move around that part, just so that way I'm even more confident of what's going to happen when I press go. Because after this screen, the next part is going to be, do you wish to start the program execution now? In this case, we're going to say yes, and it brings us into the status screen and then executes this program. Now, as I mentioned, this program is a good little trade show part, so we can customize the engraving here. In this case, we're going to select DATRON Neo Pro, and I'm going to select OK, and it's going to go ahead and immediately start executing that program.
That's great. So you can watch it in real time, it looks like, as well, to kind of really have an even closer look as to what the machine is doing while it's machining.
Yeah, it's all that much more better on how to see what's going on that part. Give me that last little bit of sanity check on how if I have anything going on wrong. We also have the color-coded flag up here. That's going to be another visual indicator. Say maybe I'm running multiple machines over a cell of machines. I can quickly see down the line the status of what's going on.
So the light just went from the green to this kind of whitish color. What exactly does that mean that's happening with the machine?
So yeah, the different colors mean different things. Kind of like those 1, 2, 3 lights that you might see on generic machining floors. They're pretty much visual indicators of what's going on to the machine. Currently, we see a blue, and that just means, hey, I'm hanging out. I'm ready to accept a new program. I'm just going to be hanging out. It's idle. The green we saw, that's I'm running a program. Sometimes if the machine can't move for a certain reason, we'll get a red. Other times the machine will be blinking a green or another color, meaning I need a user to input or interact with me. I need a confirmation. Maybe I need a value set or something of the sorts.
Yeah, that could be really valuable. Like you said, when you have multiple machines running, it's a quick at a glance of where do I need to go right now and what is, okay, I don't have to worry about that machine. It's running, it's fine. So for a production environment, that seems like a very useful tool and a good key indicator to have.
Yeah. All of production is all about efficiency and making sure you can track all those parts and making sure you can manage that high volume just the most efficient way possible. So we try to make it easy for you to do that by that flag. You have the visual indicator on the screen and all that stuff just to better help that user be able to run their part.
Awesome. Well, that's great, DJ. Now, when we saw it milling there in real time, when I look at other CNC machines, you can see the flood coolant coming in. I mean, it's very apparent, but I didn't see anything happening there. So can you explain to me about how that works with the Datron?
Yes, yes. So the Datron, our kind of bread and butter are more vacuum holding and non-ferrous materials. So our default is going to be minimum quantity lubrication in the form of alcohol or ethanol. And the reason why we choose that is because, if you put rubbing alcohol on your hands and then you do something like that, or even hand sanitizer, and your hands get real cold, we're applying that effect to our tool. So that way your tool stays cool, your part stays cool, and because it's ethanol, you don't have to worry about that gross oil residue that's left over with some other coolants or anything like that. So what you might have not even seen it, but there was an alcohol spray going on. And the focus there is it's as minimum as needed. So pretty much the alcohol is evaporating almost instantaneously and being, for lack of a better term, eaten up by the heat of the tool in the part.
Very cool. And I believe, if I remember correctly, there was something new with the Neo Pro that the Neos and the other models don't have regarding like for production value. Could you explain more about that?
Yeah, so I might have mentioned that the whole entire casting has been redesigned. It's a little
Yeah.
bit more, it's more rigid, so that way you're able to hold those tighter tolerances and get a little bit more repeatable. Not only that, the Pro itself is equipped with linear scales in your axes. And essentially, your linear scale is a real-time feedback loop to tell the machine precisely where are you in 3D space. Most of the time, a machine moves and says, I've moved X amount, so I should be there. This machine, with the linear scales, will say, I've moved X amount, and then that feedback loop, the linear scale, will say, you've actually moved so-and-so amount, and it will correct itself and compensate itself. Now, in the realm of CNC, what that does is it lets you compensate for those uncontrollable environmental factors, such as thermal growth. We all know that, especially in today's season, we get those cold mornings and maybe those hot afternoons, and it's sometimes really hard to compensate that in a shop floor. So the thermals, or the linear scales, will actually be able to compensate for that in real time.
Great. So, and I mean, who really would benefit from this kind of tolerance level? Because, I know some companies like we really just need to cut out a part. It needs to be a ballpark estimate. But then there are also some industries that really need, I mean, high tolerance parts. So who would be like the best customer, or what would be the best application for the linear scales on the Neo?
I would say any bet, I would say the best thing to do is going to be have a conversation with our applications team, and we're going to be able to best direct you to whatever machine is going to really be best for you. But all in all, if you want to hold plus or minus a thou, you're going to be good with the whole entire machine lineup of the Neo family. But if you want to start pushing into the realm of tenths, that's when you're really going to want to start focusing in on a machine like the Pro, because it has those linear scales.
Right, right. So you said that the tolerance it can hold up to a tenth.
I would say into the realm of tenths, we can that number can fluctuate depending on your application, and we could definitely get with you and provide those specific ISO dimensions if you wish. You can get offline with us to the applications team, and we're going to work with you to get those exact numbers that you're trying to look for. But all in all, the easy number to hit is all across the Neo line. We can hit a thou all day long, but if you want to start pushing it into the realm of tenths, you're going to want to focus in on the Neo Pro.
Yeah, that's great. And I mean, what type of customers are doing that type of work and need those types of tolerances?
Yeah, so we have, it's almost kind of limited to your imagination and as such, but we have customers working microfluidics, which is essentially
Mm.
coating with fluid, and they need to have some very, very precise and narrow channels to be able to control flow of fluid very, very precisely. So those tolerances are needed, or sometimes even certain people making medical devices, or even high tolerance aerospace parts.
Wow, that's great. So, I mean, so it sounds like there's a range of applications that people using the Neo are already using it for, adding it into their manufacturing production lines. And it's funny because we've traditionally heard of, or we've seen that, people view the Neo as more of an R&D type of machine rather than a true production, on the manufacturing line type of machine. Would you say, does this change with this new Neo lineup?
I would say that the Neo Pro is definitely, we've received our customer feedback. We've listened to you guys. We've listened to say, hey, this machine's great, but it needs to do something a little bit extra for production. So we've listened to that, and this is that answer. We've added more rigidity. The microjet has more capacity. We have a more repeatable probe, those linear scales like I keep mentioning. All in all, this is kind of going to be more that production geared Neo.
Okay. And you said that there's more ethanol tank. Like, what do you mean by that exactly?
So the traditional Neo and Neo Entry, they carry the 2-liter ethanol tank, while this one has the 9-liter microjet tank. So you
Wow.
have tremendously more volume there. So that way you don't have to go and get that. With the machines having a flow sensor, you would get an alarm if the machine was low on ethanol. You get that a lot less. So you can worry about the other stuff that you need to do, like maybe part quality checks or anything else. You don't have to worry about the Neo. It's making its parts for you.
Okay, great. I mean, it definitely does sound like it is more geared toward a production type of environment. All the features are making it a little more hands-off, like you can kind of set it and just let it run. Are there any software options that are also available that kind of allow the user to set the parts up and let it run and maybe potentially monitor it from a different room or from their desktop?
Yes, we have a whole list of suite of apps called DATRON Live. And essentially what that does is it allows you to remotely access your machine and kind of monitor what's going on. And depending on the set of apps that you get, maybe you can even pass a couple of programs through and execute those from a remote distance. But either way, you're going to be able to monitor and kind of see what's going on with your machine from a different location.
Wow, that's really cool. It definitely sounds like, in a production environment, this software and this control allows for, individuals like the machinists or whoever is running the machine. I mean, really, it could be anybody running the machine to not necessarily have to have a lot of experience because it is so user friendly, and you don't have to be standing in front of the machine to be making sure that it's running the way it's supposed to. Yes, that's great. Are there any other Next Control features that stand out to you that would help support a production type of environment?
So downtime is unfortunately inevitable. And so the thing is, we want to try to limit that as much as possible. A cool feature to the next machine is remote maintenance. Sometimes you don't have the time for the overnight tech to come over to your machine and fix that. You need that hot job out today. So what you could do is you could call up our service techs, our applications techs, and we can go ahead and log on to your machine and remote diagnose or maybe even fix your machine live in that moment. So that way you don't have to wait for us to get on a plane, come out to you. You can get back to making parts almost immediately.
Wow, that's fantastic. That definitely saves, so like top of the line, cutting edge, different than what I think maybe other people have with other types of machines. So that definitely saves downtime, because you're right, downtime is time that you're not making parts. When you're not making parts, you're not making money. So
Yeah.
that's great.
Yeah, so sorry to interrupt. Go ahead.
No, go
Yeah,
ahead.
so that's only one of a few apps that I feel like really emphasizes the production. We have other apps or options like sister tooling, where we kind of encourage that if you're going to do more of a high run, lights out, kind of more unmonitored type of machining, where you can set time lives to your machine tools. And once they achieve those time lives, the machine will lock them out, and then it will move to the next duplicate exact same tool and apply those same lifespans to that tool. So that way you can set up 72-hour runtime on Friday, press go, and set up maybe 8 or 9 tools that you know are going to just do its wear on a part. And then by the time you come in Monday, it's gone through. You have no tool breakage because the machine changed over tools at the right time, and you're good to go. And then another time, another app or option that I see is surface profiling that allows you to make pretty much a 3D map of your stock. So sometimes we have some stock issues where a stock manufacturer isn't giving us the best quality stuff. We can go ahead and compensate for those imperfections without having to resource stock from a more expensive supplier, or maybe even have downtime where we had to get a new, better piece of stock.
That's great. Wow. So, I mean, this Neo really does stand out as different, for sure. Not only in the way, right, that it looks, but also these features as well. And I'm just kind of curious, this is something maybe we should have started with, but what are the types of materials that it can cut? I mean, does this machine cut steel, or what are the most common materials that we see on being used on a Neo?
So what I like to say is a spinning tool is a spinning tool, and it can cut through anything that tool will allow it to. So most of the time, your limiting factor is your physical tooling more than the machine itself. However, we do shine in certain areas. So like those non-ferrous materials, like I mentioned, brass, aluminum, plastics, stuff like that, even foam. We have people cutting camera case foam, toolkit foam, stuff like that. But you did mention steel. We have plenty of customers out there fully producing parts or even engraving steel. So the machine's plenty capable of doing that.
That's great. Okay, awesome. So, I mean, it really sounds very versatile in what this machine can kind of tackle when you're trying to cut out your parts. And to be honest with you, just looking at the Neo, this is another thing that we see coming a lot on social media. It is a smaller machine. I mean, it is marketed as it can fit through a doorway, but I think people in the industry are used to kind of these bigger machines. Can you speak to its rigidity and what that means for performance? Because I know you mentioned that there's some new features for this Neo, but what about the other Neos in the lineup?
So the other Neos are still that same Neo casting that we've always trusted. And what helps with those is there's actually additional weight added to the base of the machine, kind of like the frame in a sense, to really add that rigidity. So to help combat inertia in a sense, those sudden movement changes in X and Y, those laws of physics are the real things that really fight against rigidity, and adding weight, adding denser material really helps fight that. And what they did in the Neo is by pouring added polymer concrete into the base and the frame of the machine to add that rigidity.
Oh, that's awesome. So that's great. So even though it's a smaller machine, maybe it looks can be kind of deceiving, would you say?
Yes, it's a small machine, but it's a heavy machine.
Yeah, okay, great. And I'm just thinking too, if people in a manufacturing type of setting, a lot of times, especially nowadays, we're going into the era more and more robots are being used and integrated to enhance that automation feature. Does the Neo have that capacity or capability to have a robot integrated with it?
Yes, we have plenty of different options to be able to integrate with this. We even have ways to integrate things directly, like say a robot or cobot, directly into our safety system with some extra components. And by doing that, if the cobot alarms out, the machine alarms out, and it's all a safety human operated cell in a sense.
Okay, great. So, I mean, that's certainly some people that is kind of a game changer because they want to be able to have that robot integration to enhance their automation. And for you personally, though, because I know DJ, you've been out in the field. I mean, how have you seen these Neos being used in a manufacturing production type of environment, just by visiting our customers?
So one of the coolest customers that I've seen is they have a row of Neos. And on top of that, they have a robot arm essentially on the rail through that row of Neos. And that robot arm is able to communicate with the machine through our simple language, have those normal handoffs, but maybe we're able to carry some variable data if we want to do that. And it's able to navigate through the row of 7 machines and be able to change parts or do whatever it needs to do autonomously.
Wow. And what would the benefit of having, I mean, you have 7 machines there, 7 Neos, is it?
Yes.
Yeah. So of having 7 Neos versus maybe some other, just other bigger machines, why are they different jobs on each machine?
So that kind of they do generally the same thing, but their mindset was trying to get more spindles for a cheaper price than say the M8. And their working area, they didn't need the size of the M8, but more spindles, more parts out the door. That's kind of their mentality. They just wanted to up their volume.
Sure. Okay. So everybody might have a different reason for the different machine, whether it be one of the Neos in the lineup or one of Datron's other machines. And now that you bring up spindle, I'm just curious, what is the spindle speeds like for this new Neo family? Is it all the same or is it different?
Yes, that's a good question. So the entry is a 1 kilowatt, 27,000 RPM spindle. The Neo and the Neo Pro are both still that 40,000 RPM 2 kilowatt spindle that we know and love.
Right, awesome. Well, thank you for walking us through this, DJ. I mean, it's great to just kind of see a hands-on live demo, kind of just poke around on the touchscreen, which is always so cool to see. We did get a question here in our chat. For shims, does the vacuum card act as sacrificial material for through cuts as to not damage the vacuum table?
Yes, that is a very good question. The vacuum card is a set or a set thickness, so we're able to go into the vacuum card, past our part into that, and kind of like what you said, use that as a sacrificial layer. So that way you're able to produce a burless part that has a clean edge, and you can go ahead and get rid of that vacuum card and then put on a new sheet later when you're ready to make the next part.
Okay, great. Thank you. And of course, I want to encourage anybody else, if you have questions, now is definitely the time to ask them. I have some questions that we get from social media, so I want to take this time to, have DJ answer those, but we will be wrapping up here soon, so please feel free to add some questions to the chat. So while people are taking the time to do that, DJ, question that we got on our social media is, what is really the difference between the Neo Series 2 and the new Neo Pro? Because for a lot of people, right, looking at it might look pretty similar.
So it does look similar, but some things that you'll notice are the front face panel. That's completely a little bit different. We have a little bit different controls. The power is in the front now rather than the back. I've mentioned a few times that whole entire recasting. The frame is different. It's more rigid. There's differences within the actual cabinet of the back of the machine as well. The linear scales are introduced on the Pro, the bigger microjet tank. All in all, the focus was to produce a production Neo.
So this is really to make manufacturing easier and to really be in that type of environment.
Yes, we saw that there could potentially be a gap where the Neo might not really fit someone's need. So we wanted to fill that gap on both ends, maybe in the high production area, or maybe the I only make one part a week area.
Yeah, okay, great. Great. Before we continue with those other questions, we have some coming in also in the chat. So is the machine able to auto replace the broken tool with the stock on the machine?
Yes. So the machine would sense that with that sister tooling software that I mentioned, the machine would sense that the tool is broken, and then it would go ahead and lock out that tool, or if it's worn out from a timeline, it would go ahead and lock out that tool, and then once it puts it away, that locked tool cannot be grabbed by the machine again. A human has to go in and change out that tool and physically interface with a part of the software to say, I've made that tool good again, and you can unlock it.
Okay, great. So that can all happen while the part is still on the machine. You don't necessarily need to be there.
Yes.
Okay, that's great. We have another machine, another question about the machine. So could you please share approximately how many hours of CNC machining you get per liter of ethanol? Trying to estimate how frequently my team would need to refill the tank.
Yes, of course. So all in all, it's going to vary considerably to your application, but a general rule of thumb will be about 4 hours per liter. And that's kind of a vague generalization because facing moves, for example, is going to consume less alcohol because you don't need to blow it into a channel. However, deep pockets are going to consume more. So it's all going to vary on the application, but about 4 hours per liter is going to be a safe guideline.
Okay, awesome. And then we have another follow-up from the initial questions for the shims. Does the vacuum card act as a sacrificial material for through cuts as to not damage the vacuum table?
Yes, by kind of that's almost like a secondary thing in a sense because you go through the paper to a certain depth, not to exceed the paper depth. But another software option that comes default on the Neo is something called protection area. So I can use this integrated probe and probe out any area, including the vacuum table, and say, machine, do not violate, do not go past this point ever, don't do it. And then I can trust even more that that accidental 10 inches might go through my part, but it's not going to ruin my vacuum table.
Okay, great. Yeah, definitely seeing some interest here in the vacuum table, of course. And then I just, before we close out, of course we have a couple more minutes left. I'm just going to pull another question that we got from our social media is how do you create a thread on your machines?
So there's multiple different ways to create a thread on the machine. Obviously, you can do it in Fusion or any CAM software that you have, but we have these CAM cycles on the next software. So in manual operation, drilling, and I have two ways that I can create a thread. Here we have thread milling for more traditional standard threads that we can select here. We can choose whatever thread that we want. Say we're dealing with metric. We have all the M options that we want. But all in all, our machine, you will require a thread mill because we do not have, our spindle is not reversible. You can't rigid tap on it. So you would create threads via thread milling. And honestly, that thread milling manual operation, I've used that plenty of times. It's really easy to slap on a hole or a part that I just need to create a bolt hole and just make a thread
Yeah.
real quick.
Oh, great. So, I mean, that's such a great feature to have as well, too. Well, DJ, I think we have come to the end. I don't see any other questions coming in, but of course, to everybody out there, if you have any questions, we're always available to answer them at datron.com. You can reach out to us. We're happy to help continue the conversations or give you a live demo with a part that may be even more geared to what you're trying to do, help you solve your manufacturing solution. So thanks, DJ, for all that you did for today. And thank you, everybody, for showing up. Have a great rest of your day. Bye.